Hey everyone, and welcome to a brand new deep dive. Today we're cracking open a career that's, well, often kind of hidden, but totally essential to science. You guessed it, it's the physics technician.
Physics
You sent
technicians.
us a ton of info articles, a whole career guide, the works.
Awesome.
So we're going deep, folks. Think day-to-day life, skills to succeed, even climbing that career ladder. Like, what does it really take? Consider this your cheat sheet.
You've come to the right place for that. See, people picture physicists, right? Lone geniuses making big discoveries.
Eureka moment, right?
Exactly. But it's a team effort behind the scenes.
Mhm.
And physics technicians, they're the ones making those moments happen.
Okay, so let's break that down. What does a physics technician actually do all day? Paint us a picture.
They're like the hands-on fixers of science. They bridge the gap, between the big ideas of physics and making them real.
So it's more than just handing beakers to the big shot physicists.
Way more. It's about getting those complex concepts and then using your skills. You design the experiment, run it, troubleshoot.
So give us an example.
Okay, imagine building a new solar panel, super efficient. A physics technician, they're right there with you, testing the materials, recording everything, finding ways to make the design even better, and they do it all in some seriously cool places.
Okay, now you're talking hazardous environments.
Yeah.
Tell me more about where these scientific adventures go down.
Oh, you'll find them everywhere. High-tech labs, those big research facilities, universities, even production plants.
Wow, so it's not all just boring labs.
Sometimes it's standard, yeah, but other times. It's a clean room, super controlled, filtered air, special suits. Like, not even a speck of dust can get in.
Sounds intense.
Microchips, those tiny things. Thank a physics technician in a clean room for that.
Wow, that's amazing. It seems like there's a ton of variety in this job, but what about the pros and cons? I mean, your guide definitely highlighted some big advantages.
It does. One of the best parts, you could contribute to huge breakthroughs in science. We're talking life-saving devices, new energy sources, the works.
That's incredible.
Right, but it's not all like saving the world every day. It's also the hands-on work, always solving problems. Plus, you can earn a good living, and there's a clear path to move up.
Okay, so it's rewarding, challenging, but realistic. It's not all lasers and clean rooms, though, right? There's got to be a flip side.
True, it can be demanding, long hours sometimes, and you got to be really precise.
Right, I bet those clean rooms aren't exactly relaxing.
And yeah, there can be hazards, especially with things like lasers or chemicals.
That makes sense. So safety is key then.
Absolutely. And let's not forget the repetitive stuff, like calibrating equipment, essential, but not always thrilling.
Right, I get that. So
Yeah.
finding the balance, right? The excitement of discovery, but the realities of lab work too.
Exactly. Knowing both sides is key to deciding if it's right for you.
That's a really good point. So let's say this IS for you. How do you stand out? Can you specialize, find a niche?
You're spot on. Specialization is huge EE in this field. In fact, the career guide has a whole section on it worth a deep dive itself. But to give you an idea, you could focus on material science, laser technology, or even an industry like renewable energy.
Like choosing your own science adventure.
Exactly. And speaking of adventures, let's talk career progression. The guide lays out 4 main stages: entry-level, junior, experienced, senior. Each one has more responsibility, more room to grow.
Okay, you've got me hooked. Let's break it down. What does an entry-level technician actually do? Baby steps into the world of physics.
Think of it like an apprenticeship. You're learning the basics, helping the more experienced folks, prepping equipment, doing basic tests, watching experiments super closely, and recording everything.
So it's not glamorous, but you're building that foundation.
Exactly. Precision is everything in physics, even at the entry level.
Makes sense. What about when you move up to junior technician? Less beaker washing, I hope.
You're more involved now, doing routine tests, troubleshooting if something goes wrong with the equipment, even learning to calibrate those fancy instruments.
That sounds more like it. So you're using those basic skills, but also problem solving more on your own.
Yeah. And that's key for the next step, experienced technician.
Okay, what does it take to reach that level?
It's about leadership. You're not just doing tasks, you're running the show, overseeing experiments, mentoring the junior staff, maybe even helping design experiments or come up with new procedures.
So it's not just what you can do, it's how well you work with others, too.
Totally. And you're seeing the bigger picture now. It's not just one experiment, it's how it all fits into the research goals.
And finally, we reach the peak. Senior technician. What does it take to get to that level of, I don't know, wisdom?
Experience, that's for sure. Senior technicians, they're shaping the lab's policies, managing budgets, leading research teams.
Wow, that's a long way from handing someone a beaker.
They might even present research at conferences or publish papers. It's a huge journey from those early days.
It's inspiring, really. You could start small and end up on the cutting edge of science.
That's amazing to see.
Okay, let's get real for a minute. Skills and knowledge. What do you absolutely need to make it as a physics technician?
It's more than just being good at physics, although that helps.
So it's like book smarts and street smarts, but for science.
Exactly. It's that blend of hard skills, the technical stuff, and then the soft skills, how you work with people.
Give us the rundown. What are the essentials?
On the technical side, mechanics are huge, and a good grasp of engineering principles. Oh, and computer skills. Those are non-negotiable these days. But it's not just knowing how to use a computer.
It's knowing the right programs, the right languages.
You got it. We're talking LabVIEW for running experiments, Python for analyzing data, maybe even CAD software for designing setups. It's a whole other world.
It's like the tech side never stops growing.
And it's only going to get more important as technology changes.
What about those soft skills, though? Any that are particularly valuable in this field?
Oh, tons. But one that often gets overlooked is attention to detail. You mess up a measurement in physics, even a tiny bit.
You could throw off the whole experiment.
Exactly. You got to be meticulous, double-check everything, spot anything that seems off. It's like being a detective for science.
I like that. A scientific detective. So you need those problem-solving skills, too.
Big time. Things go wrong, experiments don't work, you get weird results.
You got to figure it out.
Exactly. And you can't be afraid to think outside the box.
So it's not just about following a recipe. It's about understanding why things work the way they do.
And if something goes wrong, you need to figure out why and how to fix it.
That makes sense. What about communication? Is that important in a field that seems so, I don't know, solitary?
It's huge EE, actually. Physics technicians, they're part of a team, remember? You got to explain complex stuff to people who might not be physicists. You got to listen to their ideas, give feedback.
So you need people skills along with your science skills.
It's a package deal.
It's like you could make this groundbreaking discovery, but if you can't explain it to anyone...
It's almost like it didn't happen.
Exactly. It's a good reminder that science isn't just about working in a lab. It's about sharing those discoveries with the world.
And to share it effectively, you need both. The hard skills to do the science and the soft skills to connect with people.
Okay, I'm convinced. A well-rounded skill set is key. But with all the technology we talked about, do you think the role of a physics technician is changing? What does the future hold?
Now, that's a great question. And you know what? The guide actually talks about this. It says that while the basics will always be important.
Adapting to new technology is more important than ever. What's coming down the pipeline that aspiring physics technicians should know about?
One word. Automation. Labs are getting more and more automated, so physics technicians will need to be comfortable with really complex systems. We're talking programming robots, analyzing tons of data from automated experiments, even troubleshooting those systems when they act up.
It's like they'll be conducting an orchestra of robots.
That's a great way to put it.
But with all this talk about automation, could machines eventually replace physics technicians altogether?
People ask that a lot, and it's a fair question. But while automation will definitely change things...
It can't replace human ingenuity entirely.
Exactly. We can think critically, solve problems in creative ways. Machines just aren't there yet. And the guide agrees. It says that the future physics technician will be more like a conductor of scientific exploration.
Using their knowledge, their tech skills, and our intuition to tackle bigger and more complex experiments.
Couldn't have said it better myself.
It's like being a captain, charting a course through the unknown world of scientific discovery. But speaking of navigating uncharted territory, let's shift gears to something that can be just as daunting. The job interview.
The interview.
We've covered the ins and outs of being a physics technician, what it takes to succeed, how the field is changing, but how do you translate all that into acing that interview and landing your dream job?
Lucky for us, you came prepared. That guide you have, it's got some really good advice on what interviewers are looking for.
It's true. We've got the inside scoop on those tricky interview questions, but we'll have to save that for the next part of our deep dive. It's pretty amazing when you think about it, the whole journey of a physics technician, starting with those basic building blocks of knowledge, and then who knows where that foundation might lead.
It's true. The possibilities are pretty much endless. And that's what we're digging into now, right? the skills, the qualities, the secret sauce that sets a physics technician up for success.
Exactly. So we've tossed around those terms, hard skills, soft skills, but what do they really mean when you're talking about this kind of career? Give us the behind-the-scenes scoop.
All right, let's start with the technical stuff, the hard skills. You got to know your physics, that's a given. But it's not just about memorizing formulas from a textbook. It's about understanding how those principles actually play out in the lab, in experiments, you know?
Right, like it's one thing to read about gravity.
Exactly. It's another thing entirely to design an experiment that measures it or calibrate a sensor that uses it or even troubleshoot a system where gravity's messing things up.
Okay, so it's about taking those theories and putting them into action. What about those computer skills we keep mentioning? It seems like that's becoming more and more important.
Oh, absolutely. I mean, computers in physics labs today, they're not just tools anymore. They're practically lab partners. Physics technicians use specialized software for everything, controlling experiments, crunching mountains of data.
So what kind of software are we talking about? Give us some examples.
Well, there's LabVIEW for one. It's a visual programming language, kind of like a digital choreographer for experiments, if that makes sense.
I kind of get it. It's like you're programming the steps of a scientific dance.
Yeah, exactly. You can use it to automate measurements, tell instruments what to do, even see your data in real time. It's wild.
Wow. What else? Besides LabVIEW, are there other programs aspiring physics technicians should have on their radar?
Oh, definitely. Python's a big one these days. It's super versatile data analysis, modeling, even making those cool visualizations that make research findings really pop.
Okay, so those are pretty specific programs. What about more general computer skills?
Well, it depends on the area of physics they're working in, but a good foundation in things like spreadsheets, data management, and even basic coding concepts can be really useful. Oh, and don't forget about CAD software. Some technicians might use that to design experimental setups or equipment modifications.
It seems like the tech side of things is constantly evolving, which makes sense for a field like physics. But let's switch gears a bit and talk about those ever-important soft skills. Are there any that are particularly prized in this line of work?
Definitely. And one that often gets overlooked is attention to detail. It's huge EE. See physics experiments. They can be incredibly sensitive. I mean, even the tiniest mistake in a measurement or calibration.
Could throw off the whole thing.
Exactly. So you got to be on top of it. Meticulous, double-checking everything, spotting any little inconsistency. It's kind of like being a detective, but instead of solving crimes.
You're solving scientific mysteries.
Right. And speaking of mysteries, let's talk problem solving. That's another one that's constantly being put to the test in physics. I mean, experiments don't always cooperate, equipment breaks down. Sometimes you get results that make you wonder if the laws of physics have gone on vacation.
So you can't just follow a set of instructions and call it a day. You got to be able to think on your feet.
Exactly. Being able to troubleshoot, think critically, come up with solutions on the fly, that's essential for any physics technician.
So it's about using your knowledge and experience to navigate those unexpected twists and turns that science throws your way. What about communication? Is that a big deal in a field that seems so, I don't know, solitary?
You'd be surprised. Physics technicians, they're not lone wolves. They're part of a team, and that means being able to clearly explain complex ideas to people who might not live and breathe physics. You got to be able to listen to their ideas too, give constructive feedback.
So it's not just about being a science whiz, it's about being a team player, being able to share those aha moments with others.
Exactly. Imagine this. You make the most groundbreaking discovery in the history of physics. I mean, Nobel Prize-worthy stuff. But you can't explain it to anyone. You can't get them as excited about it as you are.
Then what's the point, right?
Exactly. It's a good reminder that science isn't just about what happens in the lab. It's about sharing those discoveries, making them understandable, even inspiring to the rest of the world.
Okay, you've definitely hammered home the point that a well-rounded skill set is crucial for any aspiring physics technician. But I'm curious, with all this talk about how technology is changing the field, do you think the role of a physics technician is changing too? What's next for this career path?
Now there's an insightful question. And you're right, technology is evolving at warp speed, and the role of a physics technician is evolving right along with it. And you know what? This guide we keep coming back to, it actually touches on that very thing. It stresses that while the fundamentals are always going to be important, being able to adapt, to embrace those new technologies.
That's becoming even more critical.
Exactly. So it's not enough to just be comfortable with the technology of today. You got to be ready for what's next.
So give us a glimpse into the future. What are some of those emerging trends that aspiring physics technicians should have on their radar? What's coming next?
One word, automation. As labs become even more automated, physics technicians are going to need to be comfortable with even more sophisticated systems. I'm talking about programming robots, analyzing massive amounts of data that those automated experiments spit out, even troubleshooting those systems when things inevitably go haywire.
It sounds like they'll be like the conductors of an orchestra, but instead of instruments, they're conducting robots and AI and who knows what else.
That's a fantastic way to put it. They'll be at the forefront, using their expertise to push the boundaries of what's possible.
Okay, so that's incredibly exciting, but I gotta ask. With all this talk about automation, could those advancements actually replace the need for human physics technicians altogether?
It's a question a lot of people have. I mean, it makes sense, right? But while automation is definitely going to change how things are done.
It can't replace human ingenuity entirely.
Exactly. We can think critically, solve problems in creative ways.
Yeah.
That's something machines just aren't quite there yet. And the guide agrees. It suggests that the physics technician of the future will be more like a conductor of scientific exploration. They'll need to use their deep understanding of physics, their mastery of technology, and that uniquely human intuition.
To design, execute, and interpret increasingly complex experiments.
Exactly. It's about leading the charge into the unknown with all the tools at your disposal.
It's like being a captain, charting a course through the uncharted waters of scientific discovery. But speaking of navigating uncharted territory, let's shift our focus to something that can be just as daunting: the job interview.
Yes. The interview. Yeah. Always a fun topic.
We've covered a lot of ground here: what it's really like to be a physics technician, the skills you need to thrive, how the field's changing. But how do you take all of that and nail that crucial interview? You know, the one that lands you your dream job.
Well, lucky for you, you came to the right place. That guide you have, it's got some really insightful stuff about what interviewers are looking for.
That's right. We've got the inside scoop on those tricky interview questions, and we're ready to share. But we'll have to save that for the next part of our deep dive. Okay, folks, buckle up because we're diving right back into the world of physics technicians. And this time, we're tackling that often dreaded hurdle: the job interview.
The interview.
But don't sweat it. We've got our trusty career guide packed with insider tips to help you totally rock it.
Think of it as your interview cheat sheet. We're going to break down those tricky questions, give you the confidence to really shine.
I love it. So the guide actually has 10 common interview questions for physics technicians. These aren't your typical, tell me about yourself, snooze fest questions, right?
No way. These are designed to see how you think on your feet, how well you understand physics, not just like the textbook stuff.
Okay, you've got to give us a sneak peek. What kind of questions are we talking about here? What do aspiring physics technicians need to be ready for?
Well, they might ask about accuracy, like how you make sure your experimental results are actually right.
So it's more than just saying, I'm really careful.
Right, way more. They want to hear about techniques, calibrating instruments, using control groups, repeating experiments.
You're proving you understand the scientific method, not just going through the motions.
Exactly, and they love those what-if questions. Testing your problem-solving skills. Like, imagine you're running an experiment and you get a reading that makes no sense.
What do you do? Oh, man, that'd be me, freaking out.
Huh. Right. But interviewers want to see a more systematic approach.
So walk us through it. What should you do if your experiment starts throwing out crazy results?
First, don't panic. Talk through the possible causes. Could be the equipment's malfunctioning, something in the environment's off, maybe even human error. They want to see you stay calm, think logically.
Like a scientific detective.
Exactly. You're gathering evidence to crack the case of the wonky experimental results.
I love that. Okay, what other curveballs might they throw at you?
They might go deep on technical knowledge. What's your experience with vacuum systems? Or how would you prep a sample for electron microscopy? Stuff like that.
So it's not enough to just know the theory. You got to know how to apply it.
100%. Hands-on experience is key.
Right.
Internships, lab courses, even personal projects. Those make a huge difference.
It's like showing, not just telling. Don't be afraid to toot your own horn a little.
Exactly. And here's a pro tip from the guide. Tailor your prep to the job description. If the role involves lasers, know your laser safety protocols inside and out.
So it's like you're showing them you're the perfect fit, you've got the skills they need.
Right. You've done your homework, you're ready to hit the ground running.
Makes sense. So to sum it up, For all those aspiring physics technicians out there, acing the interview is about showing your passion, your knowledge, and your problem-solving skills.
Don't forget those soft skills too.
Yeah.
Being enthusiastic, a good communicator, a team player, those are huge.
Absolutely. Well, folks, we've reached the end of our deep dive into the fascinating world of physics technicians. We've explored the day-to-day, the skills you need to thrive, the exciting future of the field, and of course, those all-important interview tips.
And remember, that career guide you sent in, it's a gold mine of information. Use it.
It's true. It's your roadmap to navigating this incredible career path. So keep exploring those resources, ask questions, and never stop pushing the boundaries of what's possible in the world of science.
We can't wait to see what amazing discoveries you'll be a part of.